On the afternoon of March 8, 1862, the senior officers of the United States Navy were watching the destruction of their wooden fleet, and there was nothing they could do about it. The Confederate Ironclad CSS Virginia had sorted from the naval base at Norfolk, Virginia, into Hampton Roads, the wide stretch of water where the James, the Nansemond, and the Elizabeth rivers meet before emptying into Chesapeake Bay, and she was doing things that no warship had ever done before in the history of naval combat. She had steamed directly into the anchorage of the Union blockading squadron, ignoring the shot that was being poured into her from the wooden frigates Cumberland and Congress, and from the shore batteries that lined both banks, and she was killing those ships with a methodical efficiency that the Union officers watching from the shore found almost incomprehensible. The Cumberland, a 24-gun sloop of war, was hit repeatedly by the Virginia's guns and did not slow down. She struck the Cumberland with her iron ram, driving it 3 feet into the wooden hull of the Union ship, and then backed away and left the ram embedded there as the Cumberland began to sink. The crew of the Cumberland fought their guns until the water reached the gun deck. The ship went down with her flag flying. 221 of her crew of 376 were killed or drowned. Then the Virginia turned toward the Congress and began to burn her with incendiary shells. Then the steam frigate Minnesota ran aground trying to maneuver and became a stationary target that the Virginia could destroy at her leisure the following morning. By the time the Virginia withdrew as darkness fell, she had sunk 1 warship, burned another, grounded a third, and demonstrated to every naval officer in the world who would eventually read the reports that every wooden warship afloat was now a potential casualty of any iron warship that chose to engage it. The Cumberland and the Congress had fired hundreds of rounds into the Virginia at point-blank range, and the Virginia had been inconvenienced. The Virginia had fired perhaps a few dozen rounds and had fundamentally altered the strategic situation of the American Civil War and the entire future of naval warfare simultaneously. The next morning, March 9th, the USS Monitor arrived. What followed on March 9th, 1862, in the shallow waters of Hampton Roads, was the battle that every naval officer in every navy on Earth was waiting to hear about, the battle that answered the questions the previous day had raised, the battle that would determine whether the iron warship was an irresistible weapon or whether some technical response to it could be devised that would restore a measure of balance to naval combat. The battle lasted approximately 4 hours. Neither ship sank the other. Both withdrew. The outcome was immediately, universally, and correctly interpreted as one of the most consequential events in the history of naval warfare, not because of what it decided, but because of what it demonstrated about the direction that naval technology had now irrevocably taken. To understand what March 9, 1862 meant, it is necessary to understand what both ships were, where they had come from, and what the specific circumstances of their construction told about the state of naval technology and naval thinking in the years immediately before their encounter. The Virginia was, in the most technically precise sense, not a new ship at all. She was the resurrected hull of the USS Merrimac, a United States Navy steam frigate that had been burned and scuttled at the Gosport Navy Yard in Norfolk when Union forces abandoned the yard in April of 1861. The hull of the Merrimac had settled to the bottom of the Elizabeth River in 12 feet of water with her machinery still aboard and her lower hull largely intact. Confederate naval officers and engineers, examining the wreck and assessing its salvage potential, concluded that the Merrimac's hull and engines could be raised, repaired, and converted into an ironclad warship with sufficient armament to challenge the Union blockade. The conversion was directed by Lieutenant John Mercer Brooke, a former United States Navy officer who had resigned his commission when Virginia seceded, and by John Luke Porter, the Confederate naval constructor at Gosport. The design they developed was one of the few genuinely novel warship concepts to emerge from American naval engineering in the period, though it owed something to the experimental ironclad batteries that the French and British had been building since the mid-1850s. The basic concept was to rebuild the Merrimac's hull from the waterline up with a casemate, a box-like armored structure housing the main battery, whose sloping sides of wood backing covered by 2 layers of iron plate 2 inches thick were intended to deflect rather than absorb incoming projectiles. The casemate structure rested on a flat deck that was itself only slightly above the waterline, giving enemy gunners very little to aim at above the protective iron sides. The armament was developed primarily by Brooke, who designed the rifled guns that bore his name, and that would prove to be among the most effective ordnance available to either side in the early stages of the war. The Virginia carried 10 guns, 4 Brooke rifles, 2 7-inch and 2 6.4-inch, and 6 9-inch Dahlgren smoothbores, originally from the Merrimac's battery. The Brooke rifles were capable of firing a heavy elongated shell with a rotating motion imparted by the spiral grooves of the rifled barrel, giving them greater accuracy and greater penetrating power at longer ranges than the smoothbore guns. The iron ram, 500 pounds of cast iron extending from the bow below the waterline, was added as a secondary offensive weapon, reflecting the Confederate engineers' correct assessment that the Virginia's gun battery might not be able to penetrate the heaviest wooden warships at certain ranges, and that the ram provided a backup option. The Virginia's machinery was the rebuilt Merrimac engines, which had been considered inadequate even before the burning and sinking of the ship, and which, after the trauma of immersion, were in even worse condition than before. They produced approximately 1,000 horsepower and gave the Virginia a maximum speed of approximately 5 knots in ideal conditions. The steering was sluggish, requiring approximately 30 to 40 minutes to complete a full turn, a limitation that would prove tactically significant in the engagement with the Monitor. The draft was approximately 22 feet, which confined her to the deep water channels of Hampton Roads and prevented her from operating in the shallower waters where the Union blockade was most effectively maintained. The displacement was approximately 4,100 tons. She measured 262 feet in length. She had been under conversion for approximately 9 months before her first sortie on March 8th, and her crew had had almost no time to drill with her weapons or to develop any operational familiarity with her handling characteristics. She went to battle essentially as a maiden voyage, crewed by men who were learning the ship as they fought her. The Monitor was a fundamentally different kind of vessel, one whose design had no precedent in previous naval experience and whose radical departure from established practice reflected the specific genius and specific limitations of its inventor. John Ericsson, the Swedish-American engineer who designed her, had been trying to interest naval authorities in the revolving turret concept for nearly a decade before the crisis of the Virginia's construction provided him with a receptive audience. Ericsson had demonstrated a working turret concept to the Royal Navy in the 1850s and had been rejected, partly because the British Admiralty was skeptical of the design, and partly because of a contractual dispute that had made Ericsson persona non grata with the British naval establishment. His subsequent approach to the American Navy before the war had also been unsuccessful. The Confederate Ironclad program changed the calculation immediately. When news of the Virginia's construction reached Washington in the late summer of 1861, the Navy Department convened an Ironclad board to evaluate proposals for Union ironclad warships. Ericsson's proposal was one of 3 selected for construction, and it was by far the most radical. The design he submitted called for a vessel whose hull would sit so low in the water that virtually nothing above the waterline would be exposed to enemy fire, mounting its entire offensive armament in a single rotating cylindrical turret that could traverse 360 degrees, allowing the guns to fire in any direction without the ship needing to maneuver. The concept was so far outside the experience of the Ironclad board's members that Ericsson was required to demonstrate it with physical models before the board would approve construction. The construction was carried out with a speed that reflected the urgency of the strategic situation. The Monitor was built in approximately 100 working days at the Continental Iron Works in Greenpoint, Brooklyn, New York, from October of 1861 to February of 1862. The workforce peaked at approximately 300 men working in multiple shifts, and the production was coordinated with an unusual degree of industrial organization, with components being fabricated simultaneously at several different facilities and assembled at Greenpoint as they were completed. The result was a ship that had never been tested, whose design had never been evaluated in operational conditions, and whose crew had never served in anything remotely like her, delivered to Hampton Roads with approximately 24 hours to spare before the Virginia's second sortie. The Monitor was smaller than the Virginia in almost every dimension. She displaced approximately 1,100 tons compared to the Virginia's 4,100. She was 172 feet long to the Virginia's 262. Her draft was only 10.5 feet, allowing her to operate in waters the Virginia could not enter. Her crew was approximately 58 officers and men, compared to the Virginia's approximately 320. Her armament was two 11-inch Dahlgren smoothbore guns, housed in a single revolving cylindrical turret, 9 feet in height and 20 feet in diameter, armored with 8 inches of laminated iron plate, formed from 12 layers of plate 1 inch thick, bolted together. The turret was driven by a steam-powered mechanism that could rotate it at approximately 1 revolution per minute. The hull below the turret was a flat deck, iron-plated, that sat only inches above the waterline at normal displacement. Below the deck and below the waterline was the main hull, containing the machinery, the crew spaces, and the magazine. The machinery, 2 vibrating lever steam engines of Ericsson's own design, produced approximately 340 horsepower and gave the Monitor a maximum speed of approximately 7 knots. Her steering was more responsive than the Virginia's, allowing her to maneuver more readily in the confined waters of the battle. The Ericsson turret was the Monitor's defining feature and the innovation that would have the greatest long-term influence on naval architecture. The ability to mount heavy guns in a rotating armored structure, traversing independently of the ship's heading, addressed one of the fundamental limitations of conventional naval gunnery. A ship armed with broadside guns, the standard arrangement for all warships from the 16th century to the 1850s, could only bring her full battery to bear on targets directly to port or starboard. Targets ahead, astern, or at oblique angles could be engaged by only a fraction of the total armament. A revolving turret carrying the entire main battery could engage targets in any direction with the same weight of fire, and a ship with multiple turrets could maintain sustained fire on targets at any bearing without the necessity of maneuvering to bring broadside guns to bear. The turret concept was not entirely original to Ericsson. Theodore Ruggles Timby, an American inventor, had patented a rotating gun tower concept in 1843 and had been arguing for its adoption by the Navy for nearly 2 decades. Ericsson acknowledged Timby's patent and paid him a royalty for the use of the concept in the Monitor's construction. The practical implementation of the rotating turret on a sea-going warship, however, with its specific solutions to the mechanical problems of rotation, sealing, and fire control, was Ericsson's work, and it was the Monitor that demonstrated the concept was operationally viable in combat conditions. On the morning of March 9, 1862, the Virginia returned to Hampton Roads with the intention of destroying the grounded Minnesota and completing the work of eliminating the Union blockading squadron. She found the Monitor standing between her and the grounded frigate. The engagement that followed was fought at ranges that varied between several hundred yards and a few dozen yards, as the 2 ships maneuvered in the shallow waters of the Roads. The Virginia's guns were too powerful for the Monitor's turret to survive a direct hit from her heaviest shells at point-blank range, and the Monitor's guns were too light to penetrate the Virginia's casemate armor at the ranges actually achieved. Neither ship had adequate information about the other's vulnerabilities, and the tactical decisions made by the commanders of both vessels reflected this uncertainty. Lieutenant Commander John Lorimer Worden, commanding the Monitor, had orders to protect the Minnesota and had no particular incentive to close with the Virginia more than necessary to achieve that protective purpose. He maneuvered the Monitor between the Virginia and the grounded frigate and fought a defensive battle, using the Monitor's superior maneuverability to avoid the positions where the Virginia's guns could most effectively engage her, and relying on the turret's rotation to maintain fire in the most favorable available direction. His crew was working with a turret mechanism they had barely practiced, in a ship whose handling characteristics they had had almost no time to learn, fighting a ship whose armament and capabilities were essentially unknown to them. Captain Franklin Buchanan had commanded the Virginia on her first sortie, but had been wounded by a musket ball through his thigh when, in the excitement of his ship's success, he had gone on deck to direct fire at the crew of the Congress, who were still firing even after their ship had nominally surrendered. The command of the Virginia on March 9th fell to Lieutenant Catesby Ape Roger Jones, Buchanan's executive officer, who had had no intention of commanding the ship in battle, and who had to take over a vessel in the middle of an engagement under circumstances that tested both his professional competence and his nerve. Jones handled the Virginia competently, attempting to find angles of attack that would allow his guns to penetrate the Monitor's turret, while avoiding the Monitor's ability to keep her guns bearing. The tactical problem for the Virginia was the Monitor's maneuvering advantage. The Virginia, with her 30 to 40-minute turning time, could not maintain a consistent bearing on the Monitor, which could rotate her turret faster than the Virginia could rotate herself. Every time the Virginia attempted to get into a position where she could fire both broadside batteries on the Monitor simultaneously, the Monitor maneuvered to present a less favorable aspect. Every time the Monitor closed to a range where her 11-inch guns might penetrate the Virginia's armor, Jones maneuvered to open the distance. The tactical problem for the Monitor was the Confederate ship's heavier armament. The Virginia's 7-inch Brooke rifles fired a 60-pound shell that hit the Monitor's turret with enough force to dent and deform the iron plating, and in several instances, to jam the turret's rotation mechanism temporarily. A direct hit from one of the Virginia's heaviest guns on the Monitor's pilot house, a small armored box forward of the turret through which Worden was conning the ship, struck so close to the observation slit that the commander was temporarily blinded by the concussion and iron fragments, and had to be led below decks for medical attention. The Monitor withdrew briefly to allow the transfer of command to Lieutenant Samuel Dana Green, who resumed the engagement and maintained the protective position near the Minnesota. The fundamental ballistic problem was one that neither ship could fully solve with the guns available to them. The Monitor's 11-inch Dahlgren guns were firing spherical cast-iron shot, the standard ammunition for smoothbore naval guns, at a powder charge that had been deliberately reduced by the Monitor's officers out of concern that the full service charge might damage the turret mechanism. The reduced charge meant reduced muzzle velocity, which meant reduced penetrating power. When the 11-inch shot struck the Virginia's 2-inch iron casemate at the ranges achieved in the battle, it was not moving fast enough to reliably penetrate, producing dents and cracks that were tactically ineffective. If Worden or Green had ordered the full service charge, the results might have been different, and the subsequent investigation into why the reduced charge had been used became a significant element of the post-battle analysis. The Virginia's Brooke rifles had the penetrating power to threaten the Monitor's turret armor at close range, but could not consistently achieve the close range required. The Virginia's draft prevented her from following the Monitor into the shallower water near the Minnesota, and the Monitor's maneuverability prevented the Virginia from getting into the advantageous close-range broadside position that her superior armament required. The Virginia attempted to ram the Monitor as she had rammed the Cumberland, but the Monitor's maneuverability allowed her to turn enough that the Virginia struck only a glancing blow that caused no serious damage. After approximately 4 hours, the engagement wound down without a decisive result. The Virginia had not sunk the Monitor. The Monitor had not sunk the Virginia. The Minnesota remained aground but had not been destroyed. The Virginia withdrew toward Norfolk, and the Monitor remained in Hampton Roads. The battle was over. The reaction around the world was immediate and enormous. Every naval power received detailed reports of the engagement as quickly as the telegraph could carry them, and the reactions in the naval ministries of Britain, France, Russia, Prussia, and every other state with a significant navy were essentially identical. The wooden warship was obsolete. Whatever uncertainty had remained after the Virginia's first sortie about whether the demonstrated superiority of iron over wood was real and lasting was eliminated by March 9th. The Monitor had demonstrated that an iron warship could fight another iron warship, that the engagement of ironclads was a viable form of naval combat, and that the future of naval warfare lay in the development of better ironclads rather than in any attempt to restore the utility of the wooden ship. The British Admiralty, which had already been building experimental ironclads since the construction of HMS Warrior in 1860–61, dramatically accelerated its ironclad program and essentially stopped ordering new wooden warships. The French Navy, which had been the first major power to deploy an ironclad vessel in combat with its floating batteries in the Crimean War, drew similar conclusions and redirected its construction program accordingly. The Russian, Prussian, and Italian navies moved toward iron construction with varying degrees of urgency. Even navies that lacked the industrial capacity to build modern ironclads immediately began planning for their eventual acquisition, because the lesson of Hampton Roads was unmistakable. The navy that faced a modern ironclad with wooden ships was going to lose. The specific impact of the Monitor's turret on subsequent naval design was more complicated and more protracted than the immediate reaction might suggest. The revolving turret was immediately recognized as a significant innovation, but its adoption was neither universal nor consistent in the years following Hampton Roads. The technical challenges of mounting heavy guns in a rotating armored structure on a sea-going ship were considerable, and the Monitor herself demonstrated several of the problems that would need to be solved before the turret could be widely adopted. The turret rotation mechanism was unreliable under combat conditions. The ventilation of the turret during firing was inadequate, filling the crew space with propellant gases. The pilot house, separated from the turret by the length of the deck, made communication between the ship's commander and the gun crews difficult and required an improvised signaling system. These problems were addressed in the subsequent classes of American monitors, which were built in considerable numbers during the Civil War and which incorporated successive improvements to the turret mechanism, the ventilation, and the overall layout of the ship. The Passaic class, the first of the improved monitors, mounted a single 15-inch Dahlgren gun in addition to the 11-inch weapon, demonstrating that the turret concept could be scaled to heavier armament. The ocean-going monitors that were built toward the end of the Civil War represented attempts to combine the monitor's turret concept with a hull form capable of surviving open ocean conditions, which the original Monitor had demonstrably not been able to do. The British response to the turret concept was channeled through the work of Captain Cowper Phipps Coles, a Royal Navy officer who had been developing his own version of the rotating turret concept independently of Ericsson, and who had been lobbying the Admiralty for its adoption since before the Battle of Hampton Roads. Coles's turret differed from Ericsson's in several important design details, including the method of support, the armor arrangement, and the mechanism of rotation. The Admiralty, under pressure from Coles and from the public attention generated by Hampton Roads, eventually authorized the construction of turret ships to Coles's design, most notably HMS Captain, a fully rigged ship with turrets, which capsized in a storm in the Bay of Biscay in September of 1870 with the loss of nearly 500 men, including Coles himself. The Captain disaster set back the adoption of the turret in the Royal Navy for several years and produced a conservative reaction in British naval design that historians have identified as a significant impediment to British naval modernization in the 1870s. The Monitor herself did not survive to see these developments. She was lost in a storm off Cape Hatteras on December 31, 1862, taking 16 of her crew with her when she foundered in heavy seas while under tow to her next assignment. Her low freeboard, which had been a tactical advantage in the confined waters of Hampton Roads, was a severe disadvantage in the open ocean, and the specific structural details of her construction that made her so distinctive made her vulnerable to the kind of wave action and shipping of water over the deck that open ocean conditions routinely produced. She had never been designed for anything beyond the coastal and riverine operations for which the Monitor type was intended, and the decision to tow her around Cape Hatteras in winter was one that her commanding officer, John Bankhead, protested before complying with his orders. The Virginia fared only marginally better. She remained in Norfolk through the spring of 1862, a deterrent against Union naval operations on the James River, even though she never again engaged Union ironclads directly. When Union ground forces advancing on the peninsula forced the Confederate evacuation of Norfolk in May of 1862, the Virginia's situation became immediately critical. Her deep draft prevented her from withdrawing up the James River to Richmond, and her crew could not sail her into Union-controlled waters. On May 11, 1862, her crew ran her aground and blew her up at Craney Island, destroying the most powerful warship the Confederacy had built to prevent her falling into Union hands. She had been in operational service for exactly 2 months and 3 days. The underwater wreck of the Monitor was located in 1873 by a lighthouse tender, and her position was periodically noted in hydrographic surveys over the subsequent decades. She lies approximately 16 miles south-southeast of Cape Hatteras, North Carolina, in approximately 73 meters of water, resting inverted with her turret crushed underneath the hull by the pressure of the fall to the seabed. The wreck was designated a National Marine Sanctuary in 1975, the first such designation in American history, reflecting its recognition as a site of exceptional historical significance. Archaeological investigation of the wreck has recovered numerous artifacts, including the turret itself, which was raised in 2002 and is currently undergoing conservation treatment at the Mariners Museum in Newport News, Virginia. The raising of the turret, after 140 years on the ocean floor, recovered from within it the skeletal remains of 2 crew members who had not been evacuated before the Monitor sank. Their identities have been the subject of forensic investigation, using the standards of modern forensic anthropology and DNA analysis, but definitive identification has not been achieved. They were interred with full military honors in Arlington National Cemetery in 2012, listed on their markers as unknown sailors of the USS Monitor, 150 years after the ship they served in changed the course of naval history. The CSS Virginia left no comparable physical legacy. The explosion that destroyed her was thorough enough that no significant structural remnants survived, and her position at Craney Island, in waters that have been disturbed by subsequent naval and industrial activities over more than a century and a half, has not been the subject of archaeological investigation comparable to the Monitor project. She exists now only in the records, the paintings, and the analysis of historians who have reconstructed her design and her 2 days of operational service from the documentary evidence that survived the Confederacy's destruction. The Battle of Hampton Roads, in the assessment of the century and a half of historical analysis that has examined it, was decisive in the most important sense. Not in that it settled the immediate military campaign it was part of, which continued for 3 more years before the Confederacy was defeated, but in that it settled a question about the nature of naval warfare that had been building since the introduction of the steam engine and the explosive shell in the first half of the 19th century. The question was whether the sailing warship of wood and canvas that had been the defining instrument of naval power for 3 centuries had a future in an age of iron and steam. Hampton Roads answered that question in a single afternoon on March 8th and a single morning on March 9th, 1862, and the answer it provided has never required revision. Wood was finished. Iron had arrived. The turret, that rotating cylinder of laminated plate-carrying guns that could fire in any direction, had demonstrated its operational viability. And the officers who served in the navies of every great power, reading the dispatches from Hampton Roads in the spring of 1862, understood that the world they had trained for, the world of the broadside battery and the ship of the line, was now historical rather than operational, a set of skills and traditions that had been rendered irrelevant by 2 ships fighting for 4 hours in the shallow water of a Virginia river mouth. They had a great deal of work to do.